and we focus on the content for today. That's going to be the plan. So so first we started our discussion with what we refer to as rule-based AI. So we looked at a specific you know kind of AI called rule-based AI, where we explicitly hard code the rules. We tell the machine explicitly what to do and how to do it. And that is where we looked at something called rule-based intelligence. And a lot of devices, a lot of gadgets that we see around us, a lot of these so-called devices or gadgets that we see around us are very good, very good applications of what we refer to as so what we refer to as rule-based intelligence. So that's effectively what rule-based AI is primarily all about. It's a kind of AI where you explicitly tell the machine what to do, how to do it, and the machine does it for you. So that is uh, what we refer to as rule-based AI. So you can think of examples like, let's say, a vacuum cleaner, a machine, a kind of a kind of a imagine it's like a washing machine. You can think of a typical some of the car application use cases that we talked about, right? Or how do you look at the use case of how an automobile works out? So these are all very good examples of rule-based intelligence, where the rules are kind of hard-coded. So you explicitly tell the machine what to do and how to do it, and the machine explicitly does it for you. So that's the idea that we looked at. And then we say that, okay, what happens if the rules are very difficult? What happens if the rules are very complex? Okay, so what happens if the you know if the rules that you end up having are very complex? If the rules are not exactly uh, something that you can program, think of it like an operating system. An operating system, the rules you can explicitly hard code, you can explicitly program the rules in an operating system. But what happens in a situation where the rules cannot be programmed? What happens in a situation where the rules cannot be explicitly hard coded? So that is where we look at a kind of uh, we look at something called machine learning based AI. Okay, so that is where we look at something called machine learning based AI, where you cannot hard code the rules. So the machine learns the rules from the historical data. Okay, uh, so you give the machine lots and lots of input output combinations, and that's the way we look at machine learning. You give the machine lots and lots of input output or XY combinations, and the machine somehow learns the rules from the data. You use different algorithms, and the machine somehow learns the rules from the historical data. And that's the way we understand the idea of what machine learning is all about. Okay, now coming to the general content. Think I'm sharing a different screen here. Just give me 1 minute. Okay, so now coming to the different types of machine learning that we have. We have something called supervised learning. So supervised learning is particularly that kind of machine learning where the outputs are known. Okay, so we explored a specific type of machine learning that is referred to as supervised learning. So we saw that. So supervised learning is that kind of machine learning where the outputs are known, the outputs are given, and if you look at it in supervised learning, what we are doing is we are exactly doing this thing. We are exactly going and giving the machine lots and lots of input output combinations or XY combinations, you can see, and the machine is learning the relationship between the X and the Y. So this is pretty much some of the use cases that we covered in the last session. If you remember, we are looking at the features of a person and trying to predict the salary. We are looking at for example, the attributes of how you're using the credit card, and based on that, we are trying to predict whether a person will default or not, or whether it's a fraud or not. Or we are looking at the different words that you're using in an email, and based on that, we are trying to predict whether the email is a spam or not. So it's like a spam detection system. So this is the crux of supervised learning. Okay, and as you can see, the learning process is guided by a supervisor mechanism where the algorithm is provided with input output pairs. So that's the crux of supervised learning. The next kind of and supervised learning can be further grouped into, if you remember, regression and classification. I hope all of you remember that. So we explored something called regression. So regression is that type of supervised learning where the output is a number. So we are trying to predict a numeric output. That is what we are trying to do in regression. And these are applications like many applications we talked about last session, like sales forecasting, asset price predictions. You're trying to predict the price of any asset, be it a house, be it a stock, gold, whatever, or for that matter, employee salary prediction. So these are all applications of regression that we have. And classification is that type of supervised learning. What is classification? It is that type of supervised learning where the output is a category. That is how we look at classification. So so the output, this is also supervised learning, but the output that you are trying to predict is categorical in nature. Okay, so based on the features of the input features, you are trying to predict whether the output will be yes or whether the output will be no. For example, customer churn prediction. Okay, so based on the features of the customer, you are trying to predict whether the customer will churn or the customer will not churn. Is it yes? Is it no? So you're trying to predict whether the customer will churn or not churn. So that is the problem that we will try to predict. Okay, so based on the features of the customer, we will try to predict whether it will churn, whether it will not churn. Okay, or for that matter, predictive maintenance. Predictive maintenance is where we are looking at the the features of the equipment, and based on that, we are trying to predict whether the equipment is faulty or the equipment is not faulty. So that is how we look at something called predictive maintenance. So based on the features, we are trying to predict whether it is faulty, whether it is not. Fault detection, predictive fault detection in machines. This could be a very good use case. Something which could be very relevant for, let's say, the entire power distribution or the electricity distribution network in our country. So there can be sensors installed in different parts of the electricity distribution network. And whenever any faults happen in the transformers or the power lines, the models will automatically detect what is the likelihood of the fault even before the fault happens. And there can be different patterns. Like there's a huge surge of flow in certain sectors, and because of that, the network is not able to take the load. And based on that, the model will predict that, okay, what is the likelihood a fault might happen. So you can prevent faults from happening even before they actually happen. And this can be extended to a lot of other things, like it could be automobiles, it can be airlines. Airlines are using this kind of thing a lot. Airline engines. So some of the major manufacturers of airline engines, like Rolls-Royce, Pratt and Whitney, these are the main manufacturing companies for airline engines. Even General Electric, GE. So GE has an aviation wing, and they are also very big in the airline engine space. And as you know, engines are the most important component of an airline. Everything else is just, that's providing the aerodynamics and all, but the actual power and all of those things are coming from airline engines. So predictive maintenance is also an extremely important component. And these are all classification problems. You're trying to predict some kind of a categorical output. Okay. So this is just a very small.
Just one
Yeah,
question, Kira.
yeah. Surya. Yeah.
Yeah, sorry. I'm sorry I'm
Yeah,
interrupting
yeah,
you.
yeah. No problem. Yeah.
So, I mean, it's very interesting to know this. So unfortunately, I missed the second session.
Right.
So this regression classification, I'm completely from a non-technical background, so I
Right,
ask
right, right,
questions
right.
in that perspective. So
Sure.
regression and classification. So again, these are based on the inputs from previous data, right? So the data which is
Exactly.
already there, existing data, you use it, and
Yeah,
then
yeah.
some of the inputs would be like the fresh inputs would be there out of it.
Huh.
Like you create some algorithms and make sure
Yes.
this data is in the is being used in the right way, because obviously the data that is
Yeah.
being used could be wrong. There could be a lot of errors that could be coming out of it.
Yeah.
um, and uh, and what happens in the predictive or what we wanted to do out of it would also have a lot of errors too, right? So it's
Yeah.
all
Yeah.
based on
Yeah.
the data that we give,
Correct. And I
if
think
I
this could be a
understand.
very simple example of what we talked about primarily in ML. It's a very simple example. You can see we give the machine lots of input-output combinations. Now that's what machine learning actually is. In machine learning, we are giving the machine lots and lots of these input-output or XY combinations, 1, 2, 3, 4, 5, 6, 7, 8. So these are the input-output combinations that we are providing. And on the basis of that, we are using some algorithm and we are building a model. So that is the crux of what we are doing in ML. We are giving the machine lots of input-output combinations or XY combinations. And and so let's say if I tell you 1, 2, 3, 4, 5, 6, 7, 8, these are the numbers I'm giving you. And I'm asking you to learn the patterns between the inputs and the outputs. You can see that. You can see the pattern between X and Y, right? Isn't it? So if
Yeah.
I tell you 1, 2, 3, 4, 5, 6, 7, 8, you can also easily understand what are the patterns between X, Y, isn't it? You can also see the patterns very clearly. And that is exactly the pattern that we are trying to learn. That is exactly what we are trying to do in machine learning, where given the data, we are using different algorithms. And in this case, the algorithm is like we are thinking in our brain, and we are trying to build some kind of an association between X and Y. That is what we are doing in machine learning. And then given some, this is what we call model training. There are two parts to it. One is called model training. Given the data, we are trying to train a model. And then given some new value of X, we are trying to find the predicted value of Y. So that is how we are able to look at it. Okay, so given the existing data, we are trying to fit a model. We are trying to learn the rules, or we are trying to learn some mathematical function given the existing data. So given the input output X Y combinations, we are trying to learn the relationship between X and Y. And then given some new X, let's say given X is equal to 9, we are trying to predict what is the corresponding Y. So given that X is
Mm.
equal to 9, we are trying to predict that, okay, the corresponding Y will be equal to 10. So that is the problem that we are particularly trying to solve.
Okay, okay,
Yeah.
got it. Yeah. Thank
So
you
that
for
is
that.
how we are able to look at machine learning. And then what is regression and what is classification? Like, for example, Surya, this is like an example of a regression problem because the output is a number. The output Y is a numerical variable. So you're trying to predict a numerical variable here. That's what we call it a regression problem. And in classification, this output Y will be categorical. That is how we define look at the difference between what is regression and what is classification. So like for example, in all these use cases, they're also happening in a very similar way. See, like for example, how do you identify predictive maintenance? How do you do this? Like if I go and ask you to do predictive maintenance, how exactly do you go and identify predictive maintenance? How will you do that? So you will actually take lots and lots of X Y combinations. This is exactly what one second. Uh, yeah, so you will take lots and lots of X Y combinations, and the X and Y combinations will be what, Surya? X Y combinations would be the X will be nothing but the features of the device, and what will be the Y? The output Y would be the input X will be the features of the device, and the output Y would be that, okay, did it did it fail or did it not fail? So depending on
Right.
the features of the device, did it fail? Yes. And when the features of the device were this, did it not fail? No. So this is how you will already know how things happened in the historical context. So when the patterns were like this, the equipment failed, let's say airline engines. So whenever any failures happen, this data will be collected. So whenever and in engines, there are like tens of thousands of sensors monitoring every single aspect of an airline engine. It is estimated in a typical flight, in a typical 2 to 3 hour flight, you're actually capturing, like we're talking about several hundreds of gigabytes of data. That's a tremendous amount of data that they're collecting every second and every millisecond in the process. And this is
Mm.
actually what the companies are doing. They're doing a lot of this machine learning to, when the aircraft lands, a lot of these pre-flight checks and post-flight checks that we talk about, a large part of that is based on this actually. Anyways,
Mm.
so we will know that, okay, given the features of the device, this failed, and given the parameters were like this, it did not fail. And we will have a lot of historical data like this. Based on that, we will build the model. We will learn the association between the inputs and the outputs. And next time a similar kind of pattern emerges, you can predict based on the parameters of the device. You can predict whether it will fail, whether it will not fail. So this is the way how we understand the idea of what we are doing in machine learning. Okay.
Got it. Got it. Yeah.
Okay, and you can relate to all the use cases in this manner. We are trying to
Yeah.
predict some non-numerical value, but in all these cases, even email spam detection, if you see, you're learning the same way. See, next time you open up your mailbox, you are actually responsible for marking the emails as spam or ham. There are
Mm.
certain mails that you will move to the you will move to the spam folder, and there are other emails that you will mark as not spam. So we are actually the person responsible for labeling the data. So sometimes the data labeling will be implicit, that is built into the process. Like for example, preventive maintenance. A human is not doing that. This is built into the process. You will already know, given certain features, did the device fail? And you will know that, okay, given these features, the device did not fail. So the X and Y are automatically getting collected in predictive
Mm.
maintenance. And in other parts of the process, the X and Y are collected by a human. A human being is labeling the data. Like for example, here, somebody will have to manually say that, okay, these are emails which are spam and these are emails which are not spam. So somebody will have to manually tag it. And that is how the machine will learn. I always give the analogy that machine learning is like a small kid. Okay, so based on whatever data you are providing, the machine will try to learn the associations. It will learn the patterns. It is like you're sitting with a small kid and explaining, okay, whenever you see something like this, it's a spam mail, and whenever you see something like this, it's a ham mail. So that is how it will learn that association in its head.
Okay.
And the
Okay.
same applies for other examples also. You can relate to it, like sentiment analysis. How do you teach a machine what is positive and what is negative sentiment? You will again give it a lot of historical data. Like you will give it reviews, so that X will be nothing but the text and the Y will be nothing but the sentiment. So given a particular review, you will predict whether the sentiment is positive or negative. And given a particular review, you will predict whether it is so you will have a lot of historical data like this, input output combinations, and based on that, the model will try to learn the association between the inputs and the outputs. So that's the way how we relate to what is what exactly is regression. Okay, I hope this gives you some
Yeah,
intuition. Yeah,
fantastic. Thank you so much.
yeah, yeah,
The more we give the
yeah.
data, the inputs,
Exactly,
the more it learns and it gives more
exactly.
variables. So it understands much
Yeah,
better what sort of
yeah.
prediction, what sort of outcome that needs to be given. So yeah, I got
Right.
it.
And
Thank you
if you
so
look
much.
at
It's
this
very
this
good.
use case, credit card fraud detection, we are all using credit cards or debit cards in some way or the other. This could also be a very good use case if you think look at it. So credit cards have been using these kinds of models for a long time. It's nothing new. Visa and Mastercard, I would say in many ways have been one of the earliest adopters of machine learning, like
Yeah,
starting right from spam detection in the credit card field, also in the financial payments in intermediaries field. I would say these companies are have been using these kinds of fraud detection models for a long, long time. It's not new at all. So again, what are we doing? What are we trying to do here? If you look at it, these are all the features. These are all the features. Uh, like all this while I was talking about inputs or X's or features, and this is exactly what I refer to as the features. The features are nothing
yeah,
but this is your X1. So these are the specific features that we are talking about. So we have the feature X1, this is the feature X2, this is the feature X3. So these are all the different features of the transaction. Is it a high value of transaction? What is the location? Is the device new or old? Is the merchant category new or unusual? This is also very interesting. Maybe it's a very new merchant category. You have never swiped in that store before, but all of a
yeah,
sudden you take your credit card to a foreign location in the middle of the night, 3 a.m., and you swipe in a merchant category POS machine that you've never used before. So this is actually what happens. Again, this is
yeah,
nothing to do with your HDFC Bank or ICICI Bank. This is not the bank process. This is controlled by the intermediaries. The
yeah,
cards are not controlled by banks. The cards are all controlled by Visa and Mastercard, and American Express, the payment intermediaries. Or in this case, in Indian context, we have RuPay.
yeah.
Those are the intermediaries that are managing all the transactions. Okay, so these are all the different features of the transaction, and on the basis of that, the model is trying to predict what is the probability the transaction is suspicious, what is the probability it is genuine. Now, again, why do I say it's a classification model? Because based on the features of the transaction, based on all these input x's, the model is trying to predict, is it suspicious, is it genuine? So that is what it is
Hmm.
trying to predict. And again, there'll be a lot of historical data. A lot of historical data will be there. Why? Because whenever any suspicious transaction happens, a person will report. You will often call up the bank and report that, hey, I think there's some problem that happened. So that is how the machine will know that, okay, whenever this kind of a transaction happened, somebody came back and said it was suspicious, it was a fake transaction. And whenever these other kinds of transactions happen where you did not take an action, the model will say it is genuine, which is why often, I mean, you will get a notification in your WhatsApp or message or phone call. Whenever you make a heavy transaction, the bank will try to confirm with you, and you
Yeah,
you often have to say yes, confirm. You'll have to give a confirmation, and the moment you do that, you as a customer are explicitly saying that yes, that's a genuine transaction. So that data is actually fed back to the system. So
yeah.
this is actually how these things are happening, behind the scenes.
So this
Things that we
system
are.
has been used for very long time, I guess, like even
Yeah,
before
yeah,
all
yeah, yeah.
this.
Absolutely,
Yeah,
absolutely. There's
AI.
a credit
Yeah.
cards, finance, payment space. These intermediaries have been there for decades, much, much
Decades,
longer.
yes.
I mean, some of the use cases we are seeing nowadays, like predictive maintenance and all, are much more recent. But I would
Yeah.
say credit card space and email spam detection space has been there for a long time.
There for
Even
long.
when I opened my first mailbox in 2007, we had spam detection then also.
Yeah.
There was Gmail then also. Google was a huge company then also. It was one of the biggest companies that time, obviously.
Yeah.
Even
Yeah.
now, of course, but we had these systems long, long back. Long, yeah. And
Yeah.
this is the way how you will go about with the system. I'm not getting to this. This is more like getting into the algorithm part, how we are constructing a decision tree to do that. But this is more like the approach. The big picture
Okay.
idea is this. This is the granular way how it actually does this kind of the prediction. All right.
Right.
So
Right. Yeah.
again, first step is you take the data, you build a model, like this kind of a decision tree based model, and finally you evaluate the performance of the model, how the model is doing. So, and that's also an important factor. So you will build a credit card fraud detection model, but how is my credit card fraud detection model actually performing? How do you know? Let's say
Mm.
you take some data and you build a model, you build a relationship, but how do you know that whether it is doing well or not? So we will use different types of classification metrics to evaluate that. And this is a different topic. We'll come back to this a little while later. So we
Okay.
will evaluate this on the test data. there'll be some test data. Before you deploy a system live, before you make it live, you will evaluate the system on some test data. And you will want to see that how your system is performing on the test data. So that is how we can evaluate the model.
Okay.
Okay.
Okay. Yeah.
All right. So I hope this is everybody's clear with this, the basic ideas. Well, just a small introductory quiz. I'm sure everyone can relate to this. So which of the following is the primary objective of classification? Which one will be this one? We talked about it already. We got
Yeah.
it. Which one will it be?
Pattern relationship in data classes. So categorizing instances into predefined classes
Exactly. Not
categories.
not A, because A will be regression.
Yeah.
B will be
Categorization.
identifying patterns and relationships. This is more of unsupervised learning. If you remember, we
Yeah.
talked about unsupervised. So supervised is more about a prediction problem, whereas unsupervised is more of identifying patterns. It's trying to find groups and clusters of data. We talked
Yeah.
about customer segmentation last session briefly. So B and D are more into unsupervised learning, whereas C will be
Yeah.
classification. Okay,
Classification.
yeah. This is again more on the metrics part. I think we did not get into this too much. Okay, all right. So now, moving on, let's let's see this one. And I think just to go back to a regression case study, we talked about regression also. So this is more of more of a application of a regression case study. So this is also an interesting thing. We are trying to estimate the revenue of a new movie that is launched. And again, these are very, very useful things that producers and multiplex owners will want to do. So it's actually a very big decision for them. How do you decide which movie will run and at what time slots they will run? Think about it. The idea is again not very different from hotels trying to plan their inventory, airlines trying to fix at what price they will sell their tickets. So anytime you have this kind of a numerical prediction, a price prediction, or a this is a kind of a regression problem. Okay, so yeah, this is also interesting. So you're trying to predict the box office revenue for a particular movie. Okay, how popular a particular movie will be. Okay, and it is very, very crucial for the film industry to forecast the potential success of a film. Okay, so you can see what are the different features that will be required. You will obviously have a lot of historical data. Okay, and you will know that okay, historically we have hundreds of movies that we have released, that Bollywood has released until now, and we will collect all their features: the ticket prices, the promotion budget, the historic sales, movie attributes. At movie attributes means say who are the actors, who are the directors, what was the plot about. And so based on all these features, the model will try to predict what is the revenue. So you can see that these are all the input x's, right? So these are all the input x's. This is like your x1, this is like your x2, this is like your x3, this is like your x4. And you will have this entire thing from the past historical movie data. And based on that, the model is trying to predict what is the output y. So that's your input output combinations that you will have. So based on these input x's, we are trying to predict what is the output y, which is the revenue. So it's the revenue that we are ultimately trying to predict. We are trying to estimate what is the revenue, that we will be getting. Okay. All right. So I hope this is absolutely clear to all of you. Just wanted to summarize this.
Just
Surya, I
wanted to
hope
say.
you're yeah, yeah,
So when we say this, the data that we get from the box office.
yeah,
So
yeah,
for example,
yeah,
the
yeah,
theaters or
yeah.
particular brand. So the data that we get, do we have sort of any cap in here? Like this is the minimum amount of information that is needed to that is needed for a better
That's a that's a
prediction.
very good question. That's a very good question. It's very relative. Like everything else in machine learning, I always say it is very relative at times. So will you have an absolute certainty that okay, you need a certain amount of data for sure? Not really, not really. See, the general thing is that the more data you have, the better the quality of your model. That's the general thing. So if
Right.
you have, let's say, 100 rows, and if you add 100 more rows, then you will generally have a better model, but that is not always the case. Like, I'll try to explain to you very briefly, from this diagram that you're able to see, Surya. So can you see
Yeah.
this? This is like, let's say, input X, and we are trying to predict output Y.
Yeah.
Again, I mean, this is considering a single feature. If there are more than two features, then you cannot represent it this way. It will be a plane or a hyperplane. Uh,
Right.
anyway, so we're just considering one input and trying to predict Y. So this is the
Right.
distribution of my data. How many points do we have? Only 20 rows of data, right? Think
Yeah.
about it. It's a scatter plot. Only 20 rows of data are there. Every dot is like an observation, a row. Now
Yeah.
think about it. You are saying that, Sign, if I have more rows of data, will it help me build a better model? So this is what a model is, right? You are okay with the straight line equation, right? Mx plus c.
Yeah.
equation of a straight line. We have all heard it, right? So what is regression? This is intuitively what regression is trying to do. Okay, so linear regression is intuitively trying to find what is the best fit. So given
Mm.
this particular distribution of data, we are in a way trying to find out what is the line or plane or surface that best fits the points. Okay, so
Mm.
this is what we are in a way trying to do. Okay, so I'm just gonna answer your question, but before that, very briefly, imagine this is x and this is y. This is like your 1, 2. This is like your 3, 4, and this is like your 6, 7. I'm just giving an example.
Yeah.
So you can represent your points this way: 1, 2, 3, 4, 6, 7. What is
Yeah.
the input-output relationship? Y equal to x plus 1. Agreed? Y equal
Mm.
to x plus 1. So you can easily fit a line that best passes through all the points. And the equation of the line would be y equal to x plus 1. That is how you can think of a straight line equation. That is
Okay.
exactly what we are trying to do in linear regression. We have a set of data, we have a set of input-output combinations, and all that we are trying to do is we are trying to find a line or plane or uh, we are trying to find a kind of a line or plane or mathematical surface that best fits the points. What is the line or plane or mathematical surface that best fits the points? We are trying to find the best fit, not the perfect fit, because nothing will perfectly fit your data, but you are trying to find in a way what is the best fit. What is it that
Okay.
best fits the points? So here also you will have an equation that looks somewhat like mx plus c. It will be in this kind of an equation form. So the best fit will always be in this kind of a form. So to answer
Mm.
your question, going back to your question again, this was just to give some backstory context. If you add 20 more rows of data, think about it. Let's say this is the
Mm.
distribution, and if you add 20 more rows, but all the points are near about here only. Let's say you
Yeah.
add another dot here, another dot here, another dot here, another dot here, another dot here. If all your 20 more rows are kind of very similar to the existing patterns, will the
Mm.
equation change? No, right? It will
Yeah.
remain the same.
It
So
remains same.
just by adding more rows of data does not guarantee that you will always have a better model. Make sense? So,
Mm. Mm. Mm.
so the point is, yes, you should generally have more records, more observations, but it should be more representative of the whole space. It should be more
Right.
representative data. So just by having more examples does not guarantee that you will always have a better quality model. You should have more examples and you should have more variability in the examples. Like for example, here, if you see x1 is only present in a very small space.
Mm.
Maybe I want to add 20 more rows of data. Here the pattern is linear, and those 20 more rows of data, maybe the pattern will look somewhat like this. Make sense? This
Yeah.
is a very
And the
interesting
line,
pattern now.
yeah, the
So
line would change
previously,
from the existing one to different. Yeah.
exactly, it will go to a
Yeah.
curve now. So
Yeah.
my point is, yes, you add more examples, you add more records, but you add more records that represent the overall diversity of the data
Yeah.
and not just a few instances. Maybe if you go back to credit card fraud detection, I want to collect a higher diversity of data, transactions from across different regions, transactions where people have transacted high values, low values, every possible variation I want to consider. And what what
Right.
what has really happened here? Previously, it was a best fit line, and now if I try to build a model, it becomes more like a best fit curve. So you can see the equation would have changed now. That's the
Right.
intuition. So yes, but generally as a practice, obviously, um, as I said, machines learn the same way kids learn. So if you give them more examples, they will learn better. But you have to give them more examples, and you also have to show them more variety of examples, so they will learn better.
Right.
That's
Right.
the way to look at it. Yeah, yeah.
Yeah. I'm
All right.
sorry, I
So this was
just
again
digressed in between.
no, that's fine. That's fine. We are just. I think it's. We're just trying to recap a little, understand. I think we just started this last week, so we are still trying to get used to the setup and other things.
Yeah.
Perfectly fine. I think we are getting to a rhythm now. Uh, from this week and next week onwards, so it's okay. Absolutely fine. Now, what I want to do, and obviously, just to also set the context and the agenda, what we will get into, and this is something that we consciously think what we want to do. Generative AI is a craze. So obviously, this initial part was to give you the foundations in terms of what AI and machine learning basically is, what it is, and now what is this thing called generative AI? What is this thing called generative AI? Because what we are looking at here, the kind of AI that we talked about was what we refer to as discriminative AI. If you looking at a customer, whether they will churn or not churn, looking at a mail, is it a spam or is it not a spam? Looking at a credit card transaction, is it a fraud? Is it not a fraud? In all these cases, we are actually looking at something called discriminative AI. That means we are focusing on classifying and predicting based on existing data. That's an important part. We are solely trying to classify or predict based on existing data. That is what we are trying to do. But in generative AI, the most important thing is that we are trying to focus on creating new data or content. And that is one of the main differences. We'll come to some use cases, what it is used for, all that we will see. But this is the main difference between what is a discriminative AI system and what is a generative AI system. So in discriminative AI, we have historical data like the examples we discussed. And you're trying to learn the patterns from that. And given a new record, given a new observation, you are trying to make a prediction. You're trying to make a prediction. That's the way how we understand the idea around discriminative AI. Okay, and what is generative AI? In generative AI, you're going ahead. In generative AI, you're going ahead and actually you're actually trying to create something new. Here also you have historical data. You're trying to learn the patterns, but you're trying to focus on create new content. That's the idea. Okay, and what could be some use cases? These are some use cases that we come across on a day-to-day basis. Use cases could be an application that summarizes customer reviews. It's a summarization engine, right? This is the same thing that you have in Gemini. So this meeting is also running, and you can also see a small on the top right corner. There's a small Gemini icon that is visible. So at every point of the meeting, you can see the meeting is getting summarized. Okay, the meeting is actually getting summarized. Okay, so everybody can will be able to see that. So this is actually what what Gemini is doing behind the scenes. Okay, so let me share that part of the screen with all of you. So I'm sure you guys know this already. I'm sure you guys know this already. But if you take a look at it, this is the thing. Can you see summary so far? Gemini is taking notes, and if you hover over it, there are settings and all you can control. But you can see that here, this is the summary of what we discussed so far. And what is going on behind the scenes? How is Gemini doing this? So number one is speech to text. Whatever I'm saying, whatever I'm speaking, it is being transcribed to text. So first we are doing a speech to text. My speech is getting transcribed to a text form. The entire transcription is actually getting stored, and based on the whole transcription, based on the complete transcription, that transcription is getting converted to a summary. So that is the generative AI based system, and the internal Gemini models are used for doing this. So that is the idea. Okay, so this is again how generative AI is different primarily from the world of what we refer to as discriminative AI. Okay, all right. Now let's continue on. What could be some other use cases? What could be some other applications of it? So we can see this one. Some other applications of this could be creation. We see a lot of these creative use cases where we are trying to create some kind of images or design tools or something. Okay, or we want to create a marketing advertisement for a company, or we want to create a mailer, a poster. So these are some other applications where generative AI is playing a big role. These are not discriminative AI cases. Now, this is the kind of stuff that we were not able to do using traditional machine learning. But here we are trying to create something new. So
Can the
summarization
strategy
pieces.
be, even the strategy creation can also be
Yes,
sort of
absolutely.
Gemini?
Strategy
Yeah,
creation, creating a financial report, any kind of creation
financial
that you are
reports.
trying to do. There is historical
Okay.
data, yes, but it's not a prediction. There's a very fine distinction between prediction and creation. In prediction, you have some mathematical model and it's trying to predict based on some new X. But creation is something different because in creation, what is getting outputted is never part of your original data. That's the biggest difference. So whenever you're using Chat GPT to create any content, that content has never existed before. It's always unique. Whereas in discriminative AI, that is not the case. Imagine I show you a picture of my phone, and the model will predict it's a phone. The output will be a phone, but it is not as if it has not seen phones before. It already knows it's a phone. It's just trying to do a mapping between input and output. That's the biggest difference. So in discriminative AI, in classical ML, you're trying to create a mapping between the features and the output. So the output is known from a certain set of categories. It is known that, okay, this is what we are expecting. But in generative AI, the biggest difference is that the output that you're getting is not known. We don't know what that output will be. Be it a summary, we never knew that summary before. So whatever I'm talking today, you could not potentially have trained a machine on this data because every time I say something is unique. So the summary that is getting outputted is completely new. It's completely novel. The marketing mail that you're creating, the poster that you're creating, the strategy that you're creating, or the email auto response that you're creating, all this is new. All this is novel. Translation is also a use case. Honestly speaking, translation is not just generative AI. Google Translate has been there for a long, long time. Even 15 years back, we had Google Translate, but the mechanisms have changed. So if you look at Google Translate, a lot of translation was happening using traditional machine learning and deep learning based methods 10, 15 years back. If I have to use a small technical term, we were using deep learning, neural networks, LSTM models. That is what was used behind the scenes. And just to help you relate to it, this could also be thought in the context of discriminative AI, where Google collected lots and lots of input-output combinations. This is how translation engines were built 15 years back. Today, the mechanisms have changed slightly, but 15 years back, Google collected lots and lots of input-output combinations. So they hired a lot of linguists. These people are called linguists. So linguists are language experts. Okay. So translation has gone through many, a huge amount of evolution through history. So if you go even before, a lot of language translation was done manually by these so-called linguists using statistical rules. Then slowly what they started doing was they slowly collecting data. They slowly started giving the machine lots and lots of English, let's say English to Chinese. So you are feeding a particular text in English and you are saying, okay, the corresponding text in Chinese will look like this. You are giving another text in English and you are saying the corresponding text in Chinese will look like this. And again, you are giving a particular text in English and you are saying the corresponding text in Chinese will look like this. You are giving the machine lots and lots of English-Chinese combinations. And based on that, we were building a mathematical model. And next time I give you a similar text in English, the model could predict what is a Chinese text. That's why I said it was based on machine learning. So a large part of language translation was happening this way. But over the last, some amount of time, we are seeing that these translation systems are also built using Gen AI. We're getting better results. And I think by the time we get into some discussions, we will talk about how that happens. Okay. Labeling. I mean, if you look at this, image editing software automatically adds labels to photos like mountains or beach. Again, this particular application, if you see, um, traditionally and historically, this is a great application of Google Photos, right? This labeling is nothing but Google Photos you're seeing. Now, again, Google Photos is not exactly, so Google Photos is not exactly just classification. So is Google Photos just doing a classification? Just give me 1 second, guys. Just give me a second. Okay, I'll just use my marker pen. So again, if you see, Google Photos was not just using classification. Okay, so Google Photos was primarily traditionally based on, again, this kind of historical input output combination that we have discussed, right? So Google Photos was also kind of based on this exact same idea, where we have lots and lots of these so-called input output combinations. So we fed the machine lots and lots of x's. X's are nothing but the pictures. Let's say we are feeding the picture of an apple, and we are saying it is actually called an apple. This is how the original data was collected. This is how exactly the original data was given. So we are again giving the machine lots and lots of input output combinations, and the machine is able to figure out the patterns on the basis of that. This is again classification. So traditionally, a lot of this was based on a supervised learning classification, but now we are seeing a lot of generative AI getting used for the same use cases. That's what I said. So particularly these two use cases, translate and label. Just wanted to mention that historically they were done using machine learning by collecting lots and lots of input output combinations. But now we are seeing a lot of generative AI and large language models actually getting used for these kinds of activities. Okay, and we will see we'll get some deeper idea how that happens. But just remember that generative AI is getting used in these systems today. Okay. And finally, retrieval is also a very, very interesting thing. Technically, it's called a RAG application. It's a term that some of you might have heard, retrieval augmented generation. We don't know that yet right now, what it is. But this is a great application of RAG, so retrieval-based systems. So how a search engine is able to fetch relevant articles based on user queries. So based on user queries, how a search engine is able to fetch relevant articles. So you ask a question, and using generative search, how it is able to retrieve the common things. So I think a great application of this would be Perplexity. So Perplexity will be a very good application of this particular thing. Let me show you. Let me show you how that looks like. So Perplexity will be a very good application of this. And if I just take you to Perplexity AI, this is how the interface will look like. And you can see this one in action. Uh, yeah, sorry. Oh, here it is. Yeah. So we can actually ask it some question. We can say, okay, what are the top what are the top what are the top tech news stories for today? And see what is happening is it's not a traditional search. What is happening here is not just traditional search, but it's more of an AI based search. So what Google has traditionally done in the search engine is it has actually tried to relate what you're typing, uh, and it's trying to match it with the keywords. There are billions of web pages that are indexed in Google's repository, and it's able to search based on keywords what the most similar matching web pages are. And that is how it ranks. The search engine, the search algorithm of Google will rank the results for you. That's how it has for a long time things have happened. But if you know today, Google also has launched something called the Google AI mode. If I just show you right now, um, this is the Google AI mode. If you just go to google.co.in, you can also access the AI mode. So the AI mode is like a very new kind of search. It's not like the traditional search that we have done. It's not like that, right? So it is like the so this is more like the um, a new kind of search where you're able to ask questions. You are able to ask questions, and it will not just return links to web pages that what is traditionally done. It will not just return that, but it will actually give answers to questions. So I will go and ask the same question in Google's AI mode. You will see. And the same question I will go and ask to google.co.in, the normal google.co.in. You will see. Look at this, all of you. If I go and ask this question to normal Google, this is how it will answer. Ignore this one. This is the generative part, but this is how it has traditionally done things, right? But is that what I want to know? Is it answering my question? No, it's not. So traditionally, search engines, like I would say, like they are very like old technologies today. But if I go and ask the same question in Google's AI mode, this is actually doing a generative AI based search, a retrieval based search. So what it is doing, it is able to look at the question I'm asking. It is able to retrieve the relevant links where the answer is present, and then it is able to summarize that answer for me here. This is what we call as generative AI. That's what generative AI is about. It's not like predicting something, but it's more like it's generating a new content based on the question I'm asking. It's a question answering based system. And the same thing Perplexity also does. Okay, you can see this is what Perplexity is also doing, and it will also list out your sources. What are the sources where it is taking from? So if I'm asking this question, it will retrieve the top tech news stories from these sources, and you can actually see what sources it has used. It has used all the top tech radar. These are some very, very popular technical blogs you will know. So Perplexity also does something very, very similar. So it will go and retrieve the answer from these sources, and then it will summarize the answer and give it to me. It's a very nice way to read news. Like if you want to read the developments over the last 20 in the last 7 days, last 1 week. It's a very nice way. You can write a prompt and you can read news stories. Okay. All right. So that's about what generative AI is. I hope everybody has a good understanding. You're able to differentiate the two pieces. Okay, and you know exactly what is what. But that was again primarily the objective of the initial part of what we wanted to achieve. Now, the next entity that we are going to enter into is this thing called large language models or LLMs. What exactly are LLMs? What do we mean by um, so what exactly do we refer to as large language models? What are LLMs exactly? What do we mean by large language models? So LLMs are effectively, I would say, They are models which are used in generative AI, and they are historically related to text data. Remember, the whole discipline of generative AI is not just focused on text. The generative AI is a very broad discipline, and generative AI is not new. The first generative models, they evolved in the year 2014. So 2014, we had something called generative adversarial networks when generative AI first evolved, and that's how things have been. It is not as if it's a new discipline, but yes, the aspect of Gen AI that we will talk about, that we will focus on, because I believe that's where the real interest area is for most of the learners right now. That's why we're going to start the conversation with that, and then we will go backwards into the other applications of Gen AI. So I will start with LLMs, but remember, LLMs are not just Gen AI. So sorry, just to correct my words, Gen AI is not just large language models. Gen AI is LLMs plus a lot of other things. So we will start our discussion with LLMs here, right? So LLMs are effectively used for generating text-based content. So this is the kind of stuff that happens in a chat GPT or Gemini. You ask a question, get an answer. Or what we saw in Perplexity, you ask a question, you get a beautiful summary of the news stories. That's what a large language model is doing behind the scenes. Okay, it is based on generative AI. It is based on generative AI principles. Okay, again, the traditional idea of a model should be clear to all of you. What we talked about on day one. It is a model that is built behind the scenes. Okay, traditional supervised learning model, given some input X, you can predict an output Y. Revenue prediction, sales prediction, Nifty prediction, predictive maintenance, will the equipment fail? That is a traditional AI ML model. Now, this is the generative AI model. So LLMs are more like a generative AI model, large language model. It's a language model that is able to generate new content. I hope everyone's aligned with the differences. Okay, so here we have discriminative AI. We talked about a whole lot of use cases here. That's generative AI. And one part of generative AI is large language models. That's the aspect that we will see. But remember, there are many other parts of Gen AI. It's not new. LLMs have only been, uh, the first large language model came up honestly in 2020, 2019 and 2018. OpenAI did release some models, but they were not large language models. They are what we call small language models. There were another term in industry we use called SLMs. So the true evolution of LLM started in 2020. 2020 is when LLMs really evolved. It really started, coming up, because in 2020, around the time of COVID, I would say it was around, I think around May 2020, when OpenAI released a GPT-3 model. That was a true large language model that we had. So yeah, so just wanted to clarify. But the generative AI revolution started in 2014, 2014. It goes a long back, because a lot of people who are new to this field think that, okay, Gen AI, LLMs, all these terms are getting used like left, right, center. So just wanted to clarify. So Gen AI is not new. Large language models are new. Large language models are a fairly new idea, but Gen AI is a much more broader discipline. There's a lot of other things that you can do in Gen AI, not only LLMs. Okay. In fact, I'll give an example to you. I'll give an example to you. Like, because as I said, like it's more the hype. It's more the hype. You have this Nano Banana tool, right? Nano Banana Pro, and everybody's talking about it. Like it's like a wow factor and all. Guys, there is no rocket science about it. We have been doing Nano Bananas things even in 2014. Yes, what has happened is maybe we are getting more accurate results, absolutely. But what we are able to achieve with Nano Banana, we were able to achieve in 2014 also, using something called generative adversarial networks. I'll ask you to go and read about it. What are GANs? So GANs were first invented in 2014. And if you have heard of something called a deep fake, I'm sure everybody has heard of a deep fake. Did you hear the term today? Maybe most of you have started hearing GPT and Gemini, all these things maybe a year back. I'm sure you have heard of deepfake even 5 years back, right? Is it new? No, it's not new. Okay, so companies are fooling us if they make us believe Nano Banana is something incredible or something. No, we have already had solutions. Yes, they were not accessible to consumers and the normal population or the general population that we have today. But we have had these technologies for a long time. It's not nothing new, I would say. Right? I'll give an example to you. Look at the application called FaceApp. FaceApp is a viral app. Even today, you can go and download, right? Especially during COVID, the whole population was sitting at home. We used to have a lot of these forwards, and people were editing their photos and all. What is new about it? Tell me. Tell me what is new about it. COVID was in 2020, right? Even before that, 2018, 19, I remember using FaceApp in 2019. It was hugely popular, hugely popular. What is FaceApp used to do? You can upload a selfie of yourself and you can create white hair. You can make yourself look like an old man. Facebook released a challenge, like 10 years younger challenge. So they said, okay, upload your picture and how you will look 10 years back or 10 years older. Well, tell me, you please tell me what is new about it. This all generative AI. These are all applications of generative AI. The same kind of stuff that Google is doing with this useless nano banana tool. So it's not like something incredibly new. So yes, so the ideas have evolved, the way we do things have evolved, but it is not as if we are doing something majorly different from what we were already doing 10 years back. So that's why I always say generative AI is not new. Generative AI has been there for a long, long time. The thing that is new, where we are seeing a lot of industrial applications and enterprise applications coming up, is what we refer to as large language models, which is what, as I said, in line with the demand, in line with the interest area. That's the aspect that we will try to focus on initially, and then we will get going into the other aspect areas as well. Okay, great. Now, moving on, let's do a little bit of the hands-on setup. I know we've been doing a lot of theory, and what I want to consciously do from here onwards is we want to do some time of the session for hands-on, and that is exactly what we want to set up right now. Let us see what is a large language model. I don't want to again go and bore you with a whole lot of theory and content and everything, because that content will go on for a long, long time. But I'm sure everybody is curious um, what exactly is LLM. Let's see that. Let's use that. And I don't mean to say go to Chat GPT and type a useless what is the weather and all that. That is not using LLM. That is all, like, that's not what we are in this course for, right? Like, then you're no different from 7 billion people on earth who are using Chat GPT in the same useless way. That is not LLM. LLM means we want to be thinking from a developer perspective. We're going to see things in a more technical perspective. We will see that. So Dhruv has a question. AR games like Pokemon Go. I would say that's a very good question. In fact, it's an excellent question. It's an excellent question. Um, I would say Dhruv is kind of an integration. Not only that, I mean, I can give an example of FIFA, the latest, the more recent developments around FIFA, and also Call of Duty. If you play those kinds of games, the first-person shooter FPS games that are there, uh, a lot of games are using, I would say, a mixture of augmented reality and uh, this generative AI. So I'll tell you why. Because again, if you play Call of Duty and Battlefield and some of these games, you will know that historically the gaming environments have always been hard coded, isn't it? Let's say you start playing Call of Duty and there is a particular plot that you're in. Again, I'm just giving an example, nothing against any country, but these are very famous plots. In Call of Duty, you will typically see a US Russia plot story, and also maybe Russian commandos come and they kidnap the US president. This is like a plot. So th- these plots are always hard coded. The gaming graphics are always hard coded, right? Where you're entering, what is the room, the details are all hard coded. And if you played these games, you will know that if you turn left, you can't open a door, right? It's not as if you can do everything. That's how things have been. Even if you go back a few years back, 3 4 years, few years back, that's how things have been. There are some doors you can open, there are some you cannot open. You can jump, but there are some areas where you cannot go, go the bounds. Believe it or not, we have games today, where generative AI is being used to create new environments. So it is kind of adapting based on how you play. So it is looking at how you play, where you're going. It is looking at the surroundings. That is kind of trying to adapt, and it's trying to create environments real time. And isn't that how a lot of real world gaming should be? Isn't it? Like, imagine you're playing a game. A game should not be bound by, um, like whatever static hard coding has been done. You are in a room, but hey, I mean, well, if I'm in a room, if I'm Shine here in this room, I can open my door. I can go anywhere in Earth, or maybe I can take a rocket and also go to space. I'm saying theoretically it should be unbounded. And that's what a lot of gaming is getting into. I'm not saying it's already there, but if you read about a little bit of gaming development, what some of the top franchisees like the Call of Duty franchisee and all these guys are doing, they're actually doing this. They're actually trying to create gaming environments based on how you play, based on where you're going, and that's where I would say generative AI is being used. I wouldn't quite say that Call of Duty is using augmented reality. I'm sorry, I take that back. AR is not being used. AR is used in Pokemon Go, but they are using Gen AI in a huge way. These some of the even FIFA, I would say, is a great example of that. Yeah, yeah, yeah. So the modern variants of FIFA is not hard coded. I mean, it kind of adapts based on how you play, and it kind of modifies it things accordingly. Yeah. Okay. Okay. Um. So what are some of the observed? Okay, now, as I was mentioning, let's come and let's see a small example of a large language model, and we'll see a very small example here what LLMs are, so that everybody can set it up. And I think for the next 5 to 10 minutes, I want everybody to feel comfortable. Uh, you can actually feel comfortable about. Yeah, GTA is another great example. I was about to talk about that. Yes, GTA. That was just came at the top of my mind. Yes, GTA. GTA is another actually very popular gaming series where they're yes. Okay. Um, So we'll use something called Grok Friends. So everybody can go to this site. I'll talk more about it. Again, I don't want to again bore you with too much theory, what it is and how it is, but I think sometimes let's just use it. Okay, let's take 5 minutes to use it, and then we will talk more about what it is and what it is doing behind the scenes. Okay. And the other aspect of this will be excuse me, the code. Just give me a second, guys. Sorry, the other aspect of this would be the code. And do not be intimidated about the code. Okay, so we will talk about the code and we'll discuss about the code as we go along. So everybody, please go to this website. I will ask you to please go to console.grok.com, and you will have to sign in. If you have a Google account, you can just sign in using a Google account. And once you sign in, you'll be able to you'll actually have a free access to the Grok API. And again, I'll talk more about APIs and other things later. I'm not getting into those technical details right now. Just want everybody to set up the environment, and at least run a very basic code so that you feel comfortable. We'll talk technically about all the platforms and other things later. Like you might have a question, hey, Simon, we have Grok. Do we have other things? Where does the cloud come in the picture? So we'll see everything. Okay. But for now, I at least want you to set it up and use and write one piece of code. That's the agenda. Very simple piece of code I want you to run. And that's what we want to do. Okay. Basic setup we will do here. So everybody, please go to console.grok. And on the top right hand side, you will see the sign in option. And you can just sign in with a Google account. And once it is done, you will see an interface that looks somewhat like this. Okay, everybody is seeing that? Let me know. Okay, Surya is done. Dhruv, Mandar, Vishwa, you guys are able to do it? Yeah. So Grok is more like an inference platform. So what is Grok? It's more of an inference platform. And there are many inference platforms out there. So this is one of these inference platforms that we are using. Okay. How can we go and use it? Well, if I just hide the code, you will see this kind of an option interface. And this looks just like a chat GPT, no, isn't it? If you ignore this system part, don't worry about the system. Okay. The system is something, let's say we do not know what it is. If you just ignore this system part, this is where we will normally interact with it, isn't it? Like we will just ask a question that, hey, what is the, or maybe I'll use a llama model. Maybe I can use a different model. If I can say, what is the weather in Delhi? If I ask a question, this is almost like interacting with a chat GPT, right? Isn't it? Think about it. What is the weather in Delhi? I will ask a question. That's interesting. I can't provide that. Okay, because yeah, anybody can answer this. Anybody? Can anybody answer why it's not able to answer? Well, I think I'm getting a little technical into this, but just curious if anybody can answer it. I will hide the reasoning because otherwise we will see the answer. Anybody knows why it is not able to answer? If I ask this question, what is the weather in Delhi? Why is it not X? Yes, very good. It is not having access to current data. Okay, so these language models are static. They do not have access to internet. They cannot query real data. So now you will have a question then, Sign, what about Chat GPT? In Chat GPT, we are able to do it, right? Okay, so here we are not able to access the live data, the real data, fine. But what about Chat GPT? In Chat GPT, we are able to do it, right? We are able to access the live data. We are able to access the real data in Chat GPT. So how is that possible? So how is it possible that in something like a Chat GPT, we are able to do it? How is that possible? That in a Chat GPT, we are able to do it? Well, so this is an important thing to keep in mind. So please keep this at the back of your mind that here you cannot do it, but in a typical Chat GPT interface, you can do it because Chat GPT is not only uh, a large language model, but in technical terms, Chat GPT is like an agentic system. So Chat GPT is like an agent. That is more like an agent in the real world. So that is exactly what Chat GPT is. But again, we will see that at a later time. What I wanted to share with you here is more like, let me go and modify the question. I'll ask more like a more generic question. How are winters usually in Delhi? This is the more general question I'm asking. And if I go and ask this question, the model will give a response, which we already understand, right? And all I wanted to do is, this is the normal interface, the UI, the user interface through which we will interact. But as a developer, if you want to do this, as a developer, if you want to do this, you will go and write the code. This is exactly what we will do in our session at a basic level. We will write this code and we will get the exact same response using this kind of an interface. We will see that. So Dhruv, does ChatGPT has its own web crawler or use some API of other search engines? Well, yes, it does. Yes, it does. So if you it's actually, again, it's a different topic. It's an agent. It's actually an agentic system. So which is why if you go to ChatGPT and ask similar queries, if I go and ask the same question in ChatGPT, that what is the weather in Delhi, it will go and search. It will use the search interface. Okay, it will searching the web. Can you see? So that search is a tool. It's more of a tool call that it does. Again, tools are a different topic, but in case you know what tools are, that is what is uses behind the scenes. So the search engine is like a kind of a tool. Okay, it is doing a kind of a tool call to figure out what kind of but it is not just a large language model, but it is also using sources and the web data and other things to figure things out. But we will see that. We'll discuss that in more detail as we go along. Okay. So for now, everybody, please ensure that you are able to see this kind of an option. And now, everybody, you can go to Google. Just open up. Just go to your Google Drive, everybody. Normal Google Drive. Okay. Or maybe I can just share this notebook with you. That will be better. Okay. Just give me a second. I'm just going to share this notebook with you. Maybe that will be better. We can do this exercise together in the class. I think everybody in this audience, you will have the classroom access. So you can actually go to classroom and, I've actually shared with you the thing. So all of you can go to your Google Classroom and you will see I've shared with you something called the IPYNB file. Because you can also take this opportunity, we can also take this opportunity for a little bit of the basic setup here. Everybody can see this. This is the classroom link that is, I'm sure everybody is added to the classroom. I can see all the students are here. So all of you are added to the classroom. You can please go here and you will see that I've added this particular file in the class notes.ipynb. Can you see? Everybody, please go here and just click on the file. See, that's the best part about Google. All the products are beautifully integrated. All the products are beautifully integrated, and you can actually go and open the file directly from your this thing. So we'll see that. Okay, everybody, just make sure you go to your Google Classroom. All of you, please go to your Google Classroom. Okay. And what we will basically try to do now is we'll try to open this particular file using something called Google Colab. That is exactly what we want to set up here. So there are a couple of ways you can do it. I think the easy way out would be you can actually grant access right inside Google. So what you can do, you can also parallelly, okay, you can also parallelly go and um, see if you're able to follow this, all of you. Let me just share this again. Yeah, so you can parallelly go to the Google Drive and see this class notes file. Just right click on it and say open with, connect more apps. Okay, right click on the file, open with, connect more apps, because you will see this file. Because see, whenever I share something in the classroom with you, this is the Google Classroom, right? So I think you need to check which which email IDs are added. And with respect to the email IDs, if you go to your drive, see there's a direct class drive folder. Can you see? So you will directly have access. So when you go to the the classroom, on the top right, you will have a class drive folder. You can click on that. That's the easy way to do it. Just click on that class drive. And once you click on the class drive, this is the Google Drive for the whole class. And all the contents will be beautifully available here. Okay, including the recordings and everything. And this is the notebook that I shared with you today. You can right click on it and you can say open with, connect more apps. Everyone, please follow this along with me. Connect more apps. And here you will see COLAB collab. Just search COLAB collaboratory. And once you are done, just go and install the collaboratory application. Just install it, all of you. It will ask you for your permission. That's okay. Click on continue. Just install collaboratory, all of you. And once that is done, that's it. Just make sure the installation is done. And after a while, it will say installed. It will say installed. So make collaboratory the default application for files it can open. Just make sure you check on this box. So next time you have any IPYNB file, next time you have any file with the extension IPYNB, if you click on it, it will directly open up in Google Colab. So things will become very seamless for us going forward. Okay, it's just a setup that we are doing. Okay, and once that is done, now you can directly click on the file. Okay, you can directly click on the file. You can come out of everything. You can come out of everything. You can come back to the classroom. You can directly click on the file and say it will give you the option that, hey, you want to open it with Google Colab, and say yes, open with Google Colab. That's it. So this is what I would like all of you to do. So make sure that you're able to open this file using this Google Colab. So you'll see an option that looks somewhat like this here. So if you are able to see this thing successfully, that means you have managed to successfully open your install your Colab, and you have managed to successfully do this. So this is the main coding interface that we will use for our sessions. This is called a Jupyter notebook, and this is the main interface that we'll be using right now. Okay, so one-time setup. Everybody, please let me know if you're able to do it. Okay. Okay. Okay, guys. So Dhruv is done, Mandar is done, Surya is done. Um, Anybody else? Vishwa is also done. Great. So you have the setup ready. Wonderful. And there is one more thing I would like you to do. Please go to Grok. Please go to Grok, and here you can go to something called API keys. I assume everybody has already signed in with your Google account. So make sure you go to API keys. API is like, okay, what is API? I'm going to just go and explain this in a very short way. What is an API? So imagine you want to charge your laptop. Okay. I'm just giving a very basic example that people can relate to. API, the full form stands for Application Programming Interface. That is what the full form stands for. So imagine you want to go and charge your laptop. What you will do? You will insert your laptop into a PowerPoint for charging purposes, right? You will go and install your laptop into a charging point for 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 getting the electricity. Now think about it, friends. When you do that, when you go and install your when you go and put it in a PowerPoint and all that, do you worry so much about how the current is coming from, where the current is coming from? Not really, right? Maybe that electricity is getting generated from somewhere. That electricity is getting generated from somewhere, but you have no idea about how that's happening, right? The electricity or the current is getting generated from somewhere, and it is being distributed all the way to your home. So that is what is happening behind the scenes, right? It is getting distributed all the way to your home. That is how it is happening. That is how it is working out. Okay. So you are simply switching on the switch, and you are simply accessing the current, but you have no idea, and you're not concerned about the details in terms of how the electricity is coming. So that is how we think of an application programming interface. You are only looking for the end result. The end result means that, okay, I have a laptop, I want to plug it in, I want to use it. I'm not worried about how the internal components are working. And that is the same thing that happens here as well. There are many applications which you just want to use. Like let's say here we have this particular language model, LLM. Some of the OpenAI models are available, some of the Moonshot. So there are different companies which have released large language models, like Google has Gemini. You just want to use them. You're not too concerned about what they have done, how they've implemented, but you just want to use these models. And that is exactly where API keys come into play. So using these API keys, you want to use these models. So go to API keys, all of you. So I have already an API key that is set up. You have to create a new API key. Just click on create new API key. And once you do that, you can just give it some random name. You can give it demo or whatever, and you can click on submit. Once you do that, your API key will be created. And make sure before you do that, before you click on OK, you copy the API key. Okay, so when you do these steps, you will have an option to copy the API key. So whatever API key that you created, you will get an option to copy it. So make sure everybody you copy the API key, whatever API key you created. You please ensure you copy it. So copy that particular API key. And after you're done, after that API creation is successful, and after you have copied the API key, please go back to your Google Colab. Please go back to your Google Colab. That's where we were before. So please go back to your Google Colab. And here, please go to the secret section. Please go to the secret section, and in that secret section, please click on add new secret. Okay, so we are back to the Google Colab, and in the secret section, you will see something like this. I'm also using it the same way that you guys are. So please go to the secret section and say add new secret. And I want you to name that API key as grok underscore API key. This one, like this. Okay, and in case you missed copying it, there might be some situations where, let's say, you missed copying the API key. So what you can do, you can just delete it and create another API key. I'll call it demo2, because grok gives you a certain amount of free access, not beyond the point, but up to a point, some access is free. So click on another API key called demo2, and I will simply go and copy the API key. This part is important. So whatever API key that you are creating, you must copy it. It will take a while to generate. Copy the API key, and then I will go back to the interface. Okay, and I will just go and paste the value, and also allow notebook access. That's it. This is the only other setup that is required. What is secret? Secret is like a password. Think of it that way. So this is a very simple way and a very useful way how you can save secrets inside Google Colab. And you will realize why we are doing this way. So for now, I would like you to just follow my instructions. Later, we will be able to connect the dots. Okay. So two things we have done. Number one, we have created the grok API key. Number one, we have copied that API key. And number two, we have gone to Google Colab Secrets and we have pasted that API key value, and we are calling it grok underscore API underscore key. Let me just ping you exactly the name I'm using. It's very important that you name it exactly like this. Why am I saying that? Because in my notebook, in my code, I have named it exactly like this. That is what we have done. So once it is done, now I will take you to the rest of the flow. In fact, because before I show you the rest of the flow, let's go back to grok again. Let's go back to that use case that I was discussing a while back with all of you. And we can do a very, very small sample code here. Everybody is okay with this? You have all created API key and you have set up the secret. Let me know. Surya, Mandar, Dhruv, Vishwa. Is it fine? This is again a one-time creation. So now that we are comfortable doing this, every time going forward when we have similar use cases, this is exactly how we can go and replicate the steps. We don't have to go back and every time do this. It's a one-time creation. Okay. Dhruv, you are also okay? So now what we will do, we will go ahead and can you show the name again? The name is I've just pinged you on chat. I pinged you on chat. Use that exact same name. Okay, let me know Dhruv once you're done. Okay, great. Now what we will do, we will go ahead and we will see a very basic way to call a large language model. So this is that same grok interface that we looked at a while back. If you remember, I was asking this question. Uh, how is usually the weather in Delhi? And I want to get this question answered. This is the way how we did it, right? How is usually the weather in Delhi? So this is the way how we will do this. So we can ask this kind of a question, and I will just change it to GPT. Don't worry about this. This is the different language models that we had. And I will click on submit. This is usually the answer that will come up, right? So the answer will usually come up this way. And all I want to do is I want to replicate the exact same behavior using code. And this is the code that is used behind the scenes. Okay, I will make a few modifications here. And again, I don't want you to worry about it right now. I will talk about all these pieces as we go along. So this is exactly the code that I will be using right now behind the scenes. Okay, so this is exactly the code I'll be using right now. Just copy it. Okay, just copy this code. I will share this code. Okay, you don't have to do this from your end. I'll copy this code. Come all the way back to Google Colab, and we will create a new code cell, and we will simply paste the code. And here you can just go and remove all these other stuff. This is all not required actually. I'll go and remove all this other stuff. Okay, these are things we will talk about later. Okay, I just want to keep things very simple for now. These are things we will talk about later, and I will go ahead and remove this entire thing. Okay, we will go and talk about all this later. That's it. This is the simple thing that I'll be doing right now. Okay, this is a simple thing that I'll be doing right now. Let me just quickly ping this particular part of the code to all of you. And before you do that, there's one more small thing that is required. You will actually have to do something called pip install grok. Okay, so I'm just showing the steps. Then I will then you can all do along with me. So you will have to pip install grok. This is a Python package that you need to install to help you work with grok. So just create a new cell. I will ping this message to all of you. This is the command that I want you to write. So you already have that notebook open. Just click on this cell above and click on the plus sign. This will help you create a new cell below that. And once you are there, you enter this command and please hit the play button. And once you do that, this command will get executed. That means it is
think,
installing the grok library. Yes, please,
I
Surya.
think the screen, you're not showing the right
Is
screen
it?
probably.
Okay, okay. Present, sorry, I think the other screen came up. Yeah, okay, okay. Yeah, here it goes, sorry. Pip install grok. So just go to this cell, click on the plus sign, and an empty cell will be created here. And here you please enter pip install grok. That means the grok library will get installed. And now you can go, and once that is done, we'll look at the next part of the code. Let me know once all of you are able to install grok.
I'm sorry, can you please re-explain that part? This pip install grok.
Huh. Pip install grok is the part where you're trying to, where you're effectively trying to install the grok thing.
No, I mean to say the process that you followed.
Huh. Click on the cell and click on the plus sign. The plus sign is what is used to create a new cell.
Yeah.
So click on the plus sign. That is how we create a new cell.
Sayan, I think the screen is completely different, is what I'm understanding. You
Yeah.
just check, yeah.
Where?
See, we are only able to see the other
Grok.
window. Yeah.
Oh, okay.
Yeah.
Okay. I think the other. You're seeing the grok one, is it? Just one second.
Yes, correct.
Okay. Just one second. So this is what we did here, Surya. Pip install grok. This is the code that we wrote exactly. Can you see my screen now? I hope this is visible now. Yeah.
It's the same
Pip install
console
grok is
grok.
what we did.
Oh.
Yeah. Sorry. This one. Yeah. We went back to the other one. Yeah. This one. Okay. Pip install grok.
Right.
Okay. Successfully installed. Okay. Great. Yeah. You were able to do it? Yeah. Click on the
So
setup and just click on the
I
plus sign. The
yeah, so
plus
I
sign is
went
you
to the
set
code.
up a new
Sorry, yeah.
code cell, and this is where you type. You type the statement I wrote, pip install grok, and you can run that cell like this. So 3 steps. First step is you create a cell. Now these are basically called cells in a Jupyter notebook, and these cells you can do multiple things. You can either write some comments, you can write some headers, some markdown syntax, or you can basically write code. So these are effectively cells in a Jupyter notebook. So first step is you create a cell, and second step is you go ahead and you kind of write some code and you execute the cell. So two-step process. How do you execute the cell? You click on the play button. Yeah, go on, please, Surya. Where are you stuck?
Yeah, I got it. I've done it.
You got it? Okay, good, good. All right. So once that is done, now you can all go ahead. So now we have installed the Grok client. Okay. Now these are all commented cells. You can just see the same Jupyter notebook. Let me show the notebook itself. Let's not go and copy anything. So now we are going ahead and so keep going down. And whenever you see this kind of a hashtag sign, the hashtag sign is effectively used for a commented cell. That means this code will not exactly execute. So these are all cells where you're doing something, but you're not exactly going to execute it. So it's a comment line, and comment lines are usually used to explain the code. A lot of times in my notebook, in all these kinds of code snippets which I share, you will see a lot of code I have and a lot of commented cells which I have. That means a lot of these hashtag based comments are given, and these comments are useful to understand what we are doing. But these comments will not, you'll typically not execute these cells. Next up, come all the way to this particular cell. And what are we doing here, friends? We are going ahead and just execute the other cell, this one. So what other things we are doing here? Number one, we are setting the Grok API key. So two things we are doing. Number one, we are setting the Grok API key from my collab secrets. So remember, in my Google Collab secrets, this is the thing you guys all did, right? You all defined a secret or a password named Grok underscore API underscore key. So we are fetching that. And these are effectively the different types of libraries or methods that we use. Okay, so this is like the collab Google Collab interface, and we are importing user data. And user data will basically contain all these secrets. And we are fetching the secrets called Grok underscore API underscore key. So the meaning of this code is we are fetching Grok underscore API underscore key, and we are assigning that to the Grok's API key, like whatever the API key of Grok is. And then we are saying client equal to Grok. Okay, I'm just trying to explain, but otherwise you don't have to worry. This is just standard interface that you will be using to connect to Grok. So this is the code that we will use to connect to that Grok website. So it is almost like we can go and access the models that we have on Grok through this particular interface. That's it. So this is just the thing that you do. And whenever you're able to successfully execute a cell, there'll be a small tick mark that will come up. This is what will happen whenever you're able to successfully execute a cell. You can specify the name of the model. The model name is the OpenAI GPT OSS 20B. So that is the name of the model that we will be using. Okay, so what is the name of the model that we will be using? The name of the model will be GPT OSS 20B. And this is what we are assigning. This is a string. We are assigning that to this variable. And we are just calling it model name. Run that code. And you can use the play button to run a cell, or you can also use something called Shift Enter or Control Enter. Those are some keyboard shortcuts you can Google out. But otherwise, just for the initial days, you can just go ahead and run your cells by clicking on the play button. Next up, what I want to do is I want to execute a very simple kind of a code for you. Okay, and this part I will just try to replicate. You don't have to worry about it. Let me just write it down for you, and then I'll share with you. So remember, the user input will be exactly what I did here. Because here I think there's a lot of other details in this Grok interface which might be confusing. So the question I originally asked was, how is usually the weather in Delhi? Let me take that, and that is exactly what my user input will be. So my user input will be, how is the weather usually in Delhi? And this is how the assistant response will be. If you want to copy some cells, what you can do, this is like the normal Control C, Control Z that will work. Let's say you're in some other notebook and you want to copy some contents, you can do a shift down, Control C, says copy 2 cells, and you can go all the way back up, and you can do Control V. So these are some normal operations that will continue happening the same way, Control V. So I'm able to replicate the exact same thing here. So what are the things we have done? We have instantiated the Grok client. Number two, we have specified what is the model that we want to use. Number three, I have defined the user input. Okay, I have defined the user input. Okay, so we have gone ahead and defined what is the so what is the specific user input, and based on that, we are able to predict what is the gen model response. You can do all this in one cell. You don't have to like create separate cells also. We can do all this in a single cell also. So if you want to do this in a single cell, you can actually do it. Let me go and share this code with all of you. And system message, and again, is something very, very different. I'll talk about it later on. And you want to create the response. So I'm just trying to do all this in a single cell. And this is another major benefit of using Jupyter notebooks. So you can actually, in a single cell, you can go ahead and do all this. Okay, I can execute the code. And this is what I would like all of you to do. Let me ping that entire code to all of you. So go and create a cell, all of you. Below the model name, just go and create a cell. Create a cell, and you type this out, and you click on the play button and see if you're also able to get the exact same answer. So this is just to tell you that whatever we did in the web interface, in the Grok cloud, whatever we did there, we were able to use one of OpenAI's newest open source models called GPT OSS, right? This is the model that we were able to use behind the scenes. So we were able to use that GPT OSS model, and we are doing the exact same thing. So here also we are able to do the exact same thing, just at using this particular Python interface. So using this particular Python interface, we are doing the exact same thing. That's the intuition.
I think this notebook is there in our classroom. The
Yes,
solved
yes.
one. Yeah.
Exactly. It's there. Yeah, it's already there. Correct. Let me know, guys, if you're all able to get the exact same answer that I'm getting. Okay, Surya, I got the response. Fine. And you will see that this is the exact same response that we also got in the grok.com website. And this is a very simple way how you can actually call large language models. So our Chat GPT and Gemini, they are all very different. They are all applications. The kind of stuff that we use on a day-to-day basis, you install an app and you use it, as very different. What we are trying to do here is we are trying to act as developers, and we are trying to build applications using these models. So we have this OpenAI GPT OSS model. That is the open source model that OpenAI has recently released. Not recent, it's been a few months actually. This is that open source model that OpenAI has released, because OpenAI has always had closed source models. Closed and open source means what? What is the meaning of open source? That means everything is open. Anybody can download, anybody can see the model weights. It's a completely open source model. There are some restrictions, obviously. It's not totally open source, but there are some restrictions OpenAI has put. But they have done it after a long time. The last time OpenAI released something open source was, I believe that was back in 2022, 2020, pre-2020, in fact. When they had GPT-2 and GPT-3. So after that, there was nothing open source from OpenAI. Okay, so this is the open source model that they released after a long time. Okay, so this is exactly the model that we are using right now as a developer. Okay, and given this particular user input, we are trying to call that language model, and we're getting this answer. Now, briefly, if I have to relate to the concepts that we have studied, whatever we have seen so far, imagine this model is like an equation. Imagine this model is like this large language model, this LLM, the GPT OSS model. This is also some kind of an equation. This is the y as a function of x equation that we have. Okay, and all that you are trying to do is you're giving some input x. The x is nothing but the user input. That is your user input. This is the user input that you're giving, and based on that, the model is generating the output response. Output response is the y. So I hope you can connect the dots. Yes, there's a lot of other things going on behind the scenes in LLMs, which honestly we're not going to get into here at this particular point in time. Okay, we'll go in a reverse direction. Okay, because things otherwise get very, very boring. See, once you see a lot of theory, and also what we want to do is we want to actually go backwards a little. We want to see how things are done, and then we will connect backwards and try to understand the underlying concepts. Okay, but these are actually done using transformers and deep learning models behind the scenes. That's what they're actually getting built behind the scenes. But at a very high level, based on the foundations we have seen, this is some kind of an equation. This is some kind of an association between inputs and outputs. That's what LLMs actually are. That's what large language models actually are. All the large language models, be it a Gemini model, be it the one that we are using, GPT OSS model, they are some kind of an association between inputs and outputs. And given some input X, the model is predicting what is the output Y. That's what it is. Okay, everybody is able to get it. Surya, how about Vishwa, Dhruv? You guys are also able to get it? Yeah. And here we have only given a very simple user message. So it's a very, very simple prompt we have written actually. Okay, so there's a lot of other ways we can write prompts, and that entire thing is called prompt engineering, which we will see in detail. But here today we have seen a very, very basic way how we can set up the interface. We have set up an API key, and we have written a very, very simple example of a prompt. Okay, all right, great. So now, okay. So now uh, just to clarify to all of you that what other kinds of platforms do we have? Is this the only way to do it? Not really. So all the other major platforms, see, is this the only platform to access large language models? No, it is not. So if you look at Grok is only one of the platforms that we used. But are there other platforms we can also use? Yes, we can. If you just take a look at it, this is where we used the Grok thing. Okay, this is the Grok platform that we used. Okay, using the API key, we were able to use it. But I can also take you to platform OpenAI. Mind you, this is not GPT. This is not Chat GPT. This is platform.openai.com. And you will typically need a billing account to do this. Okay, so I have an account. I'll just quickly show you how it works out. You can actually go to the dashboard, and you can see you can access any kind of model here. Same way you have to go to API keys. You will have to set up an API key. The same way you will have to set up an API key and a secret API key here. But for that, you need a billing account actually. If you don't have it, it will not ask you to enter this page, but I have it already. So I can click on create a chat prompt. Okay. And then here you can do something very, very similar. Okay. You can choose from a whole host of GPT models. This is the latest 5.2 model that OpenAI has released. Okay. You can see I can, so just like we access the this GPT OSS model, the idea remains exactly the same for any other provider as well. Okay, so once you learn one kind of approach, you can extend it to other ideas as well. So that's your GPT 5.2 Pro model. And if you want to use it, well, you can click on the code. Now we already know this, right? We already know how this will work. See, it is a very, very similar interface. The only difference is we were saying client equal to Grok. If you look at the code, what code did we write? We just said client equal to Grok, isn't it? If you remember, we said client equal to Grok. Rest, everything else will be the same. This is chat completions create. This is the method. We will specify the name of the model and we will write the prompt. User is user message. If I go to the platform OpenAI, it's exactly the same. You will specify the name of the model, which is 5.2 Pro. You will specify message is equal to. Inside it, you will write your user message, and this is client equal to OpenAI. That is the only difference. So the code that you write to access the OpenAI APIs will be exactly the same as the code that you use to access the Grok API. The only difference is, if you're accessing the Grok API, you can only access a list of models from this list. And these are all open source models because Grok is pertaining to open source models. Open source models means the models are openly available. Anybody could use it. There are no restrictions, right? It's freely available. It's freely downloadable most of the time. Like some very popular open source models are Llama. Llama is the language model by Meta, the parent company of Facebook. And another very, very popular open source model is called Mistral. So Llama is a very, very popular open. So Grok is meant for open source models. If you want to access any of the open source models, you can access all these open source models from here. Whereas OpenAI API, this is not open source. You cannot access a GPT 5.2 Pro model for free. No, you will have to pay a lot. It's a very, very costly model. So, but the interface remains very, very similar. Okay, so we are talking more about model access. And similarly, if you go to console Anthropic, I just wanted to show you the platforms here. The ideas are very, very similar. This is the, mind you, again, I'm not going to cloud.ai. I'm going to cloud developer platform, the Anthropic developer interface. There's a difference. I told you that we are not like 7 billion people, installing ChatGPT and writing useless queries, but we are trying to build applications. We're trying to build applications. That there's a difference. We're not just trying to use that, because using that you don't need to learn, right? We are all using that like we all know how to use it, right? You can type a question, get an answer, but we are users of these. We are building applications using it. That's what the developer platforms are very important. You should know what these things are. Okay. So now you can actually continue with Google. Let me just quickly show you an example. So that's your clouded developer platform, and you can actually see that the interface will remain very, very similar. The overall interface will remain very similar, and you can see only some of the methods will vary. But again, the core idea here is to tell you that similar to Grok, we were saying client equal to Grok. Here we will say client equal to Anthropic. And in OpenAI, we will say client equal to OpenAI. But you can see the broad messages portion will remain very, very similar. So the messages section will remain very, very similar here. Okay. Only difference is in Anthropic, they say client messages dot create. Okay. OpenAI, we use client dot chat completions dot create. Here we are using client dot messages dot create. Otherwise, you can see model equal to model name, messages equal to this, and there are some other things which is not required right now. But the template remains very, very similar. And the same applies to Google Gemini also. Okay, let me ping you these links actually. This is console.anthropic, and the other main player is Gemini. And for Gemini, you can access these Gemini models using something called Google AI Studio. They give you a fair amount of free usage also. Okay, you can actually get a lot of free usage using these platforms. So that is your Google AI Studio. You can access your Gemini models and the code using something called Google AI Studio. This is the link to that. And again, the interface will be very, very similar. And finally, just to conclude our conversation in terms of how we go and write a prompt, what are the basic ideas around a prompt? What we have seen here is a very basic example of a prompt, right? We just wrote, how is the weather in Delhi? It was a very basic example of a prompt. But what we can now do is, we can add more detail to it. We can add more detail to it. And this exactly is what is referred to as prompt engineering. This is going to be the next part of our discussion. We will talk about prompt engineering and what are the different types of prompt engineering techniques that we have. What are the different ways that we can write a prompt? How can we make a language model give very good quality results if we can write our prompts in a different way? So that is the exact thing that we will see in detail. Okay, so just wanted to
Just one
understand
question.
how. Yes, please. Yes, Surya. Yeah.
So for this, based on what you said, what I understood is that you're going to use some of the open source, something like what ChatGPT may not have, or maybe some other I don't know what you call, but those Grok, so you use them here to build some applications, right? So on your own.
Exactly.
So you're going to use their sources, like for example, this data which is coming up, the weather in Delhi, right? So ChatGPT might provide some sort of information on the weather. Gemini might provide a different kind of, maybe similar, but a few of them would be different.
It might be
More
different.
quality data would be from a different. So you may not be. So how do you, like, maybe this would be the question which is not relevant now. So you need to decide which one is much quality providing one, and then which one is very efficient.
You're talking more about how do we evaluate the quality of responses,
quality of response, and even can you put multiple APIs in one single so that you can
100%. 100%. That's a very good point to raise. That is exactly how things are done in the real world. In the real world, what will happen? Enterprises, Surya, will have multiple APIs. So they will have APIs for OpenAI. And let's say if I'm the manager of my project, I will probably have two APIs. One for the OpenAI API, and the second is the Anthropic API. I want to build a model. I want to build some application. Let's say if it's a code specific application, I want to, let's say a very common use case nowadays is you want to use a language model to generate test cases. And usually Anthropic models do very good, very well in terms of code, because those models internally are very well trained on the code specific data. Okay, so what I will do, option number one, I will use the OpenAI API and I will generate responses using the GPT models. And option number two, I will use the Anthropic API and I will generate responses using the Anthropic Cloud A models. Got it? So we will use both the API keys. We will write the exact same code and we will get two different responses the same way. Response number one using the OpenAI API, we will just have to define two clients, client equal to OpenAI, client equal to Anthropic. That's it. We will get two responses, and then, as you rightly said, we will have to evaluate those responses. Now that's a different topic. We'll see that later. But evaluation can happen in two ways. Number one, there can be some ground truth data that you can collect. There might be some ground truth. That means, as a developer of the application, you will already know what kind of results you're expecting. Okay. Number two, evaluation will happen through human in the loop approach. We call it human in the loop. That means you will send the results of the language model to the human experts, and those human experts will evaluate and they will give the feedback in terms of which is the better result. So that is so both the approaches are used. The human in the loop you can understand already. So you take response one, give it to a human, response two, give it to a human, ask them which one is better. So that is the way you rate.
Yeah.
The second approach is a little bit more technical, which we'll see later. There are BERT scores and all that we use to semantically understand which is the better quality of response. But that's a very valid point. Like, how do we generate, use different models, and how do we get different responses and evaluate which one is better? And Surya, that approach also works with respect to trying different prompts. So not just about using different models, but also by modifying the prompt in different ways. See, I can ask the same question in many different ways. I can give I can say how is usually the weather in Delhi, or I can ask this. I can actually write this prompt in a more detailed manner. I can give more context. I can ask this question in a more detailed manner, isn't it?
Yeah.
So the same question I can ask in many different ways, and even then let's say I will ask this question in two different ways. I will get both the responses and I can evaluate which response is better. So what you asked, the question that you asked, that we will try different models, we will try different APIs and evaluate responses. The same thing also extends to prompts. We will try different prompts, prompt one, prompt two. We will try different ways of writing a prompt. We will evaluate the quality of responses we are getting by writing different prompts, and we will choose which prompt is performing better. And that exact approach is what is referred to as prompt engineering. That is why we call it prompt engineering, because we try different variations of a prompt. This is a very basic example, but we'll extend this thing. We'll try different prompting techniques, and we will see that which particular prompt is giving us the best results in terms of evaluation methods like human in the loop or other techniques which we will see. Okay. Yeah.
Awesome. Thanks so much.
Okay. Thank you. So now, okay. So now what I want to do, we can just look at one final demo before we close. We're almost just striking 12:30, so we just spend one final demo we will see just before we close. So right now, what we have seen is a very basic prompt, right? You just got this chat completions create model name, and the prompt is what we have written. And now what we will do, we will try to understand this prompt structure in a more detailed manner. If you see in my notebook, I've actually listed down these things very nicely. I've actually given you what the different aspects of a prompt are. And these are the three very important aspects of a prompt. So prompts presented for inference have to follow a specific structure with three roles: system, user, and assistant. We have only discussed user. Now we will see something called a system message. So system message is a set of instructions that have to be followed by the LLM, which are defined by the developer of the application. So imagine you are creating an application. You are responsible for explicitly specifying what is it that you want the application to do. That is what we call the system message. And that's why we say that a big part of what we are doing in these sessions is we are trying to create applications. We are not just users of ChatGPT, because ChatGPT is already our available application. There is nothing that you can change there. So here, when we are using these developer APIs, like what we are using now, we can specify a system message exactly the way we want to do. So this is like the system message is like the overall behavior of your system. You can explicitly specify what you want the system to do, what is the input, what is the output, how you want things to happen. So that is what you will specify in the system message. User message is the input that you're providing. And on the basis of that, this is the response that the LLM will give. The system message again is what defines the overall behavior of the large language model. That this is what it's supposed to do. This is the input. This is the output, and everything else. That is what we define the system message. User message is where we explicitly, it's like a placeholder. It's a placeholder for users to present their input. That is a user message. And based on that, we will predict what is the assistant response. So based on that, we will have the assistant response. So that's the way we will go about it. So based on that, we will go and predict what is the assistant response. Let us see a small example of this in action. And what I will do to make it a little easy so that you are all able to connect the dots better, I want to first run this example in the Grok interface, and then we will go and extend this conversation to the code interface, okay? Because this is easier to follow. Let's go to Grok, and all of you can do this along with me, okay? So let me go to the code again. So this is the thing. This is your system message, okay? Let me type it out, then I'll give you some time to read this, okay? That's my system message, and that is my user message. Okay, so let me type this out, then I'll allow you time to read this, okay? Okay, so all of you give it a read, please. Just give it a read exactly what we are doing. Just read the left-hand side part. Ignore the code, please. Let me hide the code. Don't worry about the code, okay? Just read this portion, all of you. And this is a very real use case of how things are happening today. This is actually one of the most fascinating applications of generative AI. So for all the use cases we talked about since last week and also today morning, I recapped all these beautiful supervised learning, predictive analytics problems. Yeah, there's a lot of things that we are doing using the traditional ML-based approaches, but I would say this is one fascinating example where generative AI is getting used a lot today. Now, these were things that we were not able to do before. Even if you go back a few years, we were struggling. So what we are seeing here is information extraction. So given some completely unstructured text data, how do we extract information out of it? So given completely unstructured text data, how do we extract information out of it? So information extraction is what we are able to observe here. So we
So
have a system.
when we go to the hospitals, the hospitals would usually scan the notes of the doctors and all,
Correct.
right?
Exactly.
So that whatever that is written there would be automatically pulled into different the relevant information, as you said, extract the
Exactly.
relevant information
Exactly.
in this
Exactly.
JSON format, right? That would
Exactly.
go to
And that
the
JSON can be fed into
electronic
some
medical
some
records.
some some backend table, because JSON follows a tabular kind of a structured format, and that JSON can be converted back to our SQL table, and you can write it back to our database. So we can have an incredible workflow where you can take completely unstructured medical notes from doctors and and everything. All the unstructured information or even prescription data can be taken, and this kind of an application can extract information out of it into a JSON, and that JSON can be converted back to a table, or like a pandas data frame, or like even a SQL table. And you can write it back to a CSV file or an Excel file, in fact. So this is a
Actually,
wonderful way where you're converting an unstructured data into a structured format.
Actually,
Yeah.
there is one more advanced thing that today you see there is an application called Sugino. I think Sugino Bhavantu is what we say, right? They named the application called Sugino. That is actually an Indian entrepreneur who has developed this. What it does, they are taking the notes, voice notes, converting it into text like this. From the unstructured text, it is extracting the data, and the data is getting stored in the tables, I mean in the backend. So that's a kind of I mean the real life translations, accent understanding, from voice to text is happening, and then from unstructured text to informed information, I mean the structured data is being collected, and we are doing some predictions, some analysis. All these things are really miraculous.
Right, exactly. And this is especially information extraction is a very, very good use case, Especially information extraction is a great use case. How do we take completely unstructured text data? And there is so much of text data. I mean, if you look at enterprises also, there is so much of text data that you are working with. It could be a bank, it could be a retail company, it could be a HR operation. So there's so much of text data and scattered documents or Word docs. Or I'm not saying text as in manual notes. Doctors and hospitals might have. I'm saying normal. You might have like thousands and tens of thousands of CSV files scattered in your system, or thousands of Excel files, or thousands of docs in your system. And how do you get that information? How do you get all of that? Okay, it could be something as simple as, let's say, resumes of candidates. You can have an HR operations company or a recruitment company which has 10,000 resumes of candidates. And what we want to do is that is completely column number.
Yeah,
Yeah, I'm back up now. Yeah,
yeah.
so
For
column
almost
number
a
one is the
minute or so,
name.
we missed you.
Yeah. Okay. So I was talking about the resume. So let's say we have 10,000 resumes in the database, and resumes are completely unstructured data. And a great application could be we are looking at the resume and trying to extract structured information out of it. Like, let's say, what is the name of the person? What is the age of the person? What is the email address? What is the phone number? What are the skills? How many years of experience? And this would be very useful because this was previously not possible. Like, again, like for a lot of other things I was talking about, generative AI, since 2014 and all that. But these applications, information extraction is something very new. And this is something that has especially picked up in the last, I would say, 1 or 2 years because of LLMs. LLMs are very good at doing information extraction, particularly with respect to text. So given any text data, you can convert it into this kind of a structured format like this. In this case, we want to convert it to a structured JSON format, and that is what that the system message is. The system message is like, defining the overall behavior of your application. This is what you're supposed to do. So look at the medical notes by doctors and extract relevant information like the age, the gender, the diagnosis, and you're also explicitly specifying that what is the value of the age. So age is supposed to be an integer. Gender is supposed to be some kind of a string value, either male or female. So you're explicitly specifying the bounds of the data also. So not only are you saying, okay, from the text, we want to extract these columns, but you're also specifying what are the bounds and what are the data types of the columns that you want to extract. And here is the medical notes that we have written, and we can click on submit, and you can see the answer that will come out. Look at this, all of you. So this is usually what you'll be seeing. So age is this, gender is this, diagnosis is this. So the Gen AI model has actually extracted this information from this medical notes based on the system message that you have written. Now, if I add something more, let's say if I add like for example, um, well, I mean, if I add one more example called medication, I can do that. I can modify this in whichever way I want. What medication has been given? Okay, what medication has been given? It's going to be a string value. Okay, it will be a string value. That's it. Uh, and let's say specify the name and dosage if given. So you see how the system message will be used to define exactly what the application is supposed to do. Okay, so the system message will be used to define exactly what the application is supposed to do, and that's it. And the user message is what the end users will enter. So in a more real world scenario, the system message you will not be seeing. Like, so let's say you are using the application in the real world, you will not have any idea what the system message is. This is typically going to be hidden from end users. This will be hidden. Let me hide it, okay? So just imagine there is no system message we have. So system message will be typically hidden. As an end user, you will only be typing this. That's what you do, right? I mean, if you think about it in ChatGPT, when you go to ChatGPT, what do you do? So what do you do when you go to chatgpt.com? You just get this screen, right? Do you type system message, user message? No, you don't. And this is what I want everybody to appreciate, that in ChatGPT application, you are only typing the user message. And then there are many other variations there, which we'll talk about later. But as an end user, you are only entering the user message here. That's it. There is no system message. You know why, friends? Because the system message is already predefined. In the ChatGPT application, the system message is already predefined. These guys have already written the system message, and you will not know what their system message is, because remember, the system message is very confidential, because system message is defining the bounds of the application. If you get to know the system message of ChatGPT, then people, the bad actors, will try different ways to hack into the system, isn't it? So that is a very serious privacy breach. So
Can
system
this
message
be
is something
edited
you
as
will.
well? System
Huh?
message can be
No, no,
edited
no,
by.
never,
Okay,
never,
that cannot be.
never. Yeah, of course not. As I
By the
told you, it will
company.
be, it's a safe. Company can. Company, of course, can. But yeah, see, I can go here and I can modify it. Of course, I can. This is my. So imagine this is my application. So I have modified the medication. Can you see? And now when I run this, when my end users come, when my doctors come and upload their medical notes, and if I run this, you will start to see the medication will also additionally come. Can you see? Can you see? Beautifully, the medication has come up right now. Okay, and let's say there is another doctor who has come. Let me go and show this to you. Let's say we have another doctor. Okay, I will go and show you how this application will work for another doctor. Sorry, for another set of medical notes. This is the more detailed one. This is the more detailed set of medical notes we have. So now this is a single application I've designed. It is supposed to work in this way. And now if I have another medical note, let's see what the response will be. Look at this. Look at this. This is how it will be working. So now end users can just attach the different medical notes. You can browse the file, and the assistant will automatically reason, and it will give you the outputs like this. So the important learning from this exercise was the concept of system message and user message. The system message is what is used to define the overall uh, behavior of your application, and user message is what the end user is entering. And if you want to see this in code, the code is really easy. Whatever I showed you here like this in code, this is how it looks like. All of you can see. So you will define a string variable called system message. In Python, this is actually called a string. So there are different ways you can write a string in Python. So I can say name equal to Shine. I can say name equal to Shine. So Python is a very flexible language. Okay, or I can say name equal to Shine. Okay, I can use something called triple quotes also to write Shine. Just remember, all of you. Okay, so there are multiple ways you can write this, and all of them are valid. All of them are valid syntaxes. Okay, so I can write Shine like this. I can write Shine like this. I can write Shine like this. All of these are valid syntaxes. And this is a particularly used format. This is a particularly used format for multi-line strings. So usually when you have a multi-line string in Python, this is the format that is usually preferred. Again, there are some technical reasons why. I'm not getting into those things, but just in case people are curious, this is used to like prevent escape sequences. Like for example, if the string itself contains a single quote, if the string itself contains a double quote, and if the string itself contains a triple quote, these things are prevented. Okay, so if I did not have a triple quote concept in Python, the moment my string itself consisted of a single or a double quote, the string will end. So to prevent that, we use these things called multi-line strings in Python. Anyways, so system message, user message, they are both strings. I'm going to run this code, and here the same code that we saw before. The only difference is we are adding an extra role system message. That's it. So user message we already had. This is the role user, and the input is the user input string. We have additionally added role system, and the system message is the system message string. That's it. So we will generate the response, and this is the response that we're getting. All of you can see. This is exactly what I saw in the UI also. Okay, so this is the kind of stuff you will do as a developer. Okay, so Grok was just the end user interface that we saw, but this is what you will do as a developer at the backend environment. And then obviously, if you want to build a front end interface, you can use applications like Streamlit or Radio and all that, and you can build a simple user interface to show how this is going to be working behind the scenes. Okay, so that's the basic idea. In case you want to, you want to actually see this in action, Again, I don't want to make it too much of a of a UI based session right now, but like we can actually create a small user interface. Whatever we are seeing, this in code, we can create a small user interface and we can simulate. We can actually simulate exactly what we are seeing, what we saw in Grok here. Okay, so maybe we can see that in the next session. So the user interface part is a different topic, but again, the focus here, we have seen the basic idea of writing a prompt, and we'll extend the conversation. We'll extend the conversation, and tomorrow we will get a little deeper into different types of prompt engineering methods. So today we just saw basic prompt, and now we will get a little deeper into things like zero shot, few shot. What are the different ways we can write a prompt? Okay, so what is this thing called prompt engineering? Will be the next focus area for us. Okay, so I think we can pause here. Everybody probably will be like I'm sure it was like some new things we learned here, and it's a good time for us to take a pause, and we will continue the session tomorrow from where we're leaving off here. Yeah.
Thank you, Sayed. I think
Thank
this
you,
wonderful.
Mr. Lakshmi. Yeah,
Yeah.
yeah.
See what
And I will continue. Yes,
what
please.
actually
Yes.
the audience here you have to you just not your takeaway from here is you should also extend your exploration beyond this classroom, because here what we are
Exactly.
doing is a small spark. You just need to spend
Yeah.
a lot of time
Yeah.
and try different prompts and stuff like that, and you
Right.
know very well now an army of, it's not just one or two, there are army of chat gpt kind of a tools are there. You can ask chat gpt, hey, this is what I'm trying to do, can you help? It will provide the code. Now you got the trick that how you copy the chat gpt code into google colab, right? And how you install a package that is dependent package. If there is some error that you are getting while you are executing the pip command, definitely that package is missing. So you need to know that how to install the package. So now you got a spark, how you install the pip pip install grok. The same way you have some names of the packages which is missing. You just need to extend your knowledge. I think you need to drag from here how you just understand the concepts here. See what we have done here. We have done a kind of open source environment, that is your google colab. And you have amazing platforms which is doing the magic here: grok, gemini, cloud A, and OpenAI, and many more will come. Actually, there are a lot many. There is a DeepSeek, something from China, Manu. There is something. There are a lot many things are there. What you just need to understand, the same idea, how you interact, connect, and send a user prompt, system prompt, and there are, so when you progress this, you can do lot many things. There are a lot of applications. I just shared what Sayan has picked up a amazing example. There is an application called sugi.ai. It was very much amazing that somebody is writing some application where they are converting the voice to text and extracting the information from the text, and then loading into the backend system of hospitals, the complete automation of the entire medical transcription, right? Is it not
Right.
raising goosebumps for us, really? I think we have been really progressing well, Sai, and I think we just wanted this kind of the a
Right.
demonstration more. And
Exactly,
yeah,
exactly. I think now I think good that people I think the environment is set up, and yeah. So this is what we'll be doing, obviously. And as Mr. Lakshmi said, like the idea would be, let's say I'm giving an example in Grok. Now, how do you explore? Maybe you can go and maybe open up a little bit of the OpenAI APIs and see how you can play with some of those similar APIs from your end. Okay. So yeah, so that's how you have to extend the learning. Correct.
great. Thank you all.
Okay. Thank you, everybody. I'll
We
see you
connect
all
on
tomorrow.
time tomorrow. Okay.
Sure. Absolutely. Yeah.
Thank you so much, and excellent
Thank you,
class.
Surya.
Thank you.
Thank you. Thank you so much. Yeah. Looking forward to see everybody tomorrow. Okay.
Yeah.
Take care, guys. Have a good day.
You too. Bye bye.